So today we are all the way up in Newcastle getting our gears for the gearbox, our splines, all inspected by a high precision bespoke machine to inspect them to see just how precise we have machined our gears. So we're here today at a place called Dontine. Me and Mark drove up this morning. It was a very long drive. Actually, I took the train and he drove, but it was a very long drive and train ride for both of us. And we're here now looking at the gears, seeing just how accurate it really has been over the past few months, machining these gears and splines for the gearbox. So yeah, let's show you what that looks like. So things are looking really good for gears at the moment. We've got a couple of the results back and some of the gears have actually come in right at spec, which is amazing. We're expecting there to be on some of them, which there are on some, a little bit of variation and things that we need to change, but it's looking really good so far, and we still have some stuff up our sleeves that we can do to get the gears right on point for specs. And we definitely are on track to accomplish what is needed for that, and things are looking really good right now. Mark's feeling good about it and he says that everything's looking great, better than expected actually, and it's on track to make a fully working and functioning at spec main rotor gearbox. So that's brilliant and we're all really happy about that. What I have behind me here is a 1960s gear grinding machine. Now, the key difference between this and the machines that we are using is really down to the flexibility of what you can do with the machine. This is a very specific purpose, and that purpose is, well, to grind out a gear, and it is used for manufacturing on huge scales. The issue is, well, first of all I should say, it works great. It does a great job, but the issue is that it can't be flexible like the machines we're using now. It can do one set thing with one tool set, but when you need to have a new tool made, it takes about 12 weeks, which is a hugely long time, especially when you're in a prototype design process. On the other hand, over here, which you can't see, are the machines that we use. And those machines can be adjusted to do many different things at many different times. Yes, they're not quite as efficient, but they give us the flexibility to achieve what we need to do for the HX50.
So that tooth shape, so the measurement styli will come in and then it'll take a scan and it'll tell you the quality of that tooth itself for your profile.
Yeah.
For your leads, what you're doing is you're seeing what the face width of the gear tooth is at a certain diameter. So the styli will come up and then it'll take a scan right across there. And for the pitch and run out, what it'll do is it'll come in at half the face width, take a point on every single flank of the tooth, and then it'll do an analysis on the deviation from each tooth.
So here we have a soft gear and a hard gear. Now the difference between these two gears is the case hardening of them, and there's a scale called the Rockwell scale. Now let me explain that a little bit. This gear here is 36 on the Rockwell scale, this is 62 on the Rockwell scale. So 36 on the Rockwell scale, 62 on the Rockwell scale. Now, what does that mean? Well, essentially this means how hard the outside is on the gears. In the middle it's still soft, so it allows for flex, so it doesn't break off because it's so rigid. But on the outside it's case hardened, so the gear from millions of cycles does not wear and tear as easy as it would with a soft gear.